So I'm going to explain single recessive epistasis. So to define epistasis, it is when two different loci unexpectedly contribute to the same phenotype. When you don't have any epistasis, you'll expect to see a 9:3 to 3:1 ratio between these four genotypes. This information comes from the lecture slides, specifically lecture video 12. I used fish as an example pathway. If there was no epistasis, you would see this 9:3 to 3:1 ratio between all of these, and the big A, big B will give you purple, because when you go from light blue, you have this big A to get to dark blue, and you also have the big B that lets you get to purple. Then there will be 3 dark blue because they have the big A, but then there's no big B, so they're stuck at the dark blue phenotype. And then for these two genotypes, there is no big A at all, so both of these genotypes will be stuck as light blue progeny. And from this, you can see that there are 9 purple, 3 dark blue, and 4 light blue. And that 9:3 to 4 ratio tells us that that's a single recessive epistasis. So this is just a table that we are given to determine the type of epistasis. And in the previous slide, I determined that this example was a 9:3 to 4 ratio. And this table just tells you that it's single recessive. And this is from video 12 of the lecture slides. So an example cross will be 2 heterozygous parents. This will just result in the same progeny as we went over in the previous slides, which will be 9 purple, 3 dark blue, and 4 light blue, since this is single recessive epistasis. And this is out of 16 offspring. For this example, I used Punnett squares to show the possible combinations of the genotypes that the progeny might have. So you'll have some big A, little a, big B, and these offspring will be purple because they have both the big A and the big B to get them to that phenotype. And it's the same thing for this genotype. And then for these two genotypes, there's no big A at all between them, so they can't even get out of the light blue phenotype. So there will be no dark blue offspring at all because there is no B inhibitor, which would be a little b. So they have no way to stay in the dark blue phenotype.